Hello, y'all. Okay, so this chapter only has 4 sections. So our first one is about linear lines and talking about slope, increasing, slope, rate of change, all that. So to start with, going over that the linear equation is y equals mx plus b, and our average rate of change, or slope, we can call it, is the y2 minus y1 over x2 minus x1. So for this first equation, we're determining if these given points create a linear line. And a linear line has a constant slope throughout any 2 points. You should always get the same slope. So I'm going to take these points, -2, 1/4, and -1, 1/2, and do our slope formula. So 1/2 minus 1/4 over -1 minus -2, and that's 1/4 over 1, which equals 1/4. Now I'm going to take the points 0, 1 and 1, 2. So 2 minus 1 over 1 minus 0. It's 1 over 1, which equals 1. 1/4 and 1 are not the same, so since the change in y over the change in x is not constant, therefore f of x is not linear. Alright, going into increasing, decreasing, and constant. So increasing when we have a positive slope, decreasing when we have a negative slope, and constant when our slope is 0. So in these A, B, C, and D, we're just determining if the equation is increasing, decreasing, or constant. And so we want to look at the slope. So whatever number is next to x. So in this case, our slope is 5, which is positive. So that means the equation on the graph, it would be increasing. In B, m is -2. That's negative. So therefore, it's decreasing. Then we have m equals 3/4. Even though it's a fraction, it is positive. So therefore, it's increasing. And lastly, there is no x here, so m is 0. So therefore, it's constant. Now we're going to look at some equations, like building a linear equation using information given to us. So write a linear function for Vx. Vx is yours says book, but I'm changing it to car, value after x years. V0 represents the original value of $28,000. So that's why I changed it to car, because I do not know any books that cost $28,000. So car seems more reasonable. So a car, the starting amount, the original value of the car is $28,000, and then the slope is $4,000 per year. And a car depreciates in value, so it costs less after years go on. So our slope here is going to be negative. So we're going to use our equation y equals mx plus b. Our m is how much it's going to change each year, by how much amount. So negative 4,000 per year. And then b is our y-intercept, which is our starting value. And our starting value is $28,000. Now that I have m and b, I can just make an equation and say y equals -4,000 x plus 28,000. The next part is we're going to graph the function, and I'm just going to make a graph here for us. So we know the 28,000 is our y-intercept. And this is just going to be a rough sketch. So now I just need my x-intercept. So we plug in 0 for y to find our x-intercept. X plus 28,000. So I'm going to subtract 28,000 from both sides and get negative 28,000 equals negative 4,000 x. Divide both sides by negative 4,000 and end up with x equals 7. So my x-intercept is 7, which is 1, 2, 3, 4, 5, 6, 7. Then connect my 2 points. So that's about a rough sketch of this linear function. Part C, what is the car value after 3 years? So our x value is our years. So after years is what counts for how much the car is going to cost. And so the cost of the car can change, and so that's why it's the y value. But years, you can't really change years, they just happen in order. So I'm going to plug in 3 for x. Y equals negative 4,000 times 3 plus 28,000. Plug that in your calculator and you get y equals $16,000. So after 3 years, the car would cost $16,000. Now we're interpreting the slope. So as we discussed, that after a year, our car is going to depreciate in value of $4,000. So the value of the car decreases $4,000 per year. When will the car value be $8,000? So 8,000, the cost is our y, so I'm going to plug in 8,000 for y. So my first step is subtract 28,000 from both sides. So negative 20,000 equals negative 4,000 x. Divide both sides by negative 4,000 and I would get x equals 5. So it would take, after 5 years, the car would then only be worth $8,000. Next one we're going to talk about is supply and demand. So our first is to find the equal price between the supply and the demand. And to find the equal price, this is when the equations equal each other. So we're going to set the equations equal to each other. And then solve for P. So I'm going to add 15 to both sides, 15P. And I'm going to add 900 to both sides. Then I would have 75P equals 3,750. Divide both sides by 75, P equals 50. Then I want to find, what, if I plug in 50, what am I going to get? So I can plug it into either one of the equations. So I'll plug it into the supply. So 60 times 50 minus 900 is 2,100. So 50, 2,100. Then determine whether the price for which quantity supplied is greater. So we're trying to find when the supply, so 60P minus 900, is greater than the demand, which was negative 15P plus 2,850. Then I'm going to solve just like I did above. So add 900 to both sides and add 15P to both sides. And I would get 75P is greater than 3,750. Divide by 75 on both sides. P is greater than 50. So in context, if more than $50 is charged, the supply will be greater than the demand. Sorry for the messy handwriting. All right, so then we're going to graph the two equations and plot the point where they intersect. So graph the two and label the equilibrium point, which we found in part A. So first, let's graph the demand. So it has a y-intercept of 2,850, so I'm going to put it there. And then it has a negative slope. And then the supply has a y-intercept of negative 900, so I'll put it about there. And it has a steeper increasing slope. And then I'm just going to label that point the 50, 2,000, 100. And that's it. Let me know if you have any